The basic flow of the fountain is configured. Adding collisions will allow the particles to bounce off of the granite sphere in the scene and eventually be deleted. You may ask, why delete the particles? For one simple reason. The more particles you have, the longer it takes to calculate. And at a certain point, the particles don't need to be seen anymore. Once they bounce off the granite sphere and into the water, they effectively disappear. Make sure the particle flow object is selected and the particle view dialog box is open. The first thing to do is test for two different collisions, one for the granite sphere and a second for the fountain water. Two separate tests are needed because when the particles bounce off the granite sphere, they need to go to a new event that will create additional particles. The second test will determine when the particles land in the fountain water. That will allow you to route those particles to an event that will delete the particles. From the operators list, click and drag the MP collision operator to the bottom of the event in the particle flow. Click the new MP collision operator. In the MP collision parameters, click the Add button. This allows you to click directly on the granite sphere in the fountain cam viewport. Click the sphere, and it is added to the deflectors list. Select the Test True If Particles option. Make sure that the Collides option is chosen. Click and drag a second MP collision operator below the first one. Click the second collision operator. This time, click Add, and select the fountain water object. The fountain water object is a transparent object, but if you click in a blue area of the fountain, it will be the first object selected. Again, select both the Test True If Particles option and the Collides option. That completes the first event. Now you need to add an event for the particles that will spawn when the water hits the sphere. Click and drag a Spawn Test event to an open area underneath the initial event. This will create a new spawn event that contains a spawn operator as well as a display operator. Click the spawn operator in the new event. In the Spawn Rate and Amount group, select the Once option. Set the offspring number to 2 and set the variation percentage to 40%. Expand the Sync By dropdown and select Particle Age. This will create 2 particles for every 1 particle that collides with the sphere. In the Speed group, choose the Inherited option to set the speed to be inherited from its parent particle. Leave the inherited number set to 100. Set the variation percentage to a value of 10%. Set the divergence to a value of 30. Since the particles are bouncing off of the sphere, add a speed by surface to enhance the bounce of the particles off the sphere. Click and drag a new speed by surface operator into the second event beneath the spawn operator. Select the Speed by Surface event. Expand the Speed by Surface dropdown and select Set Speed Once if it is not already selected. Set the speed value to 4 feet and the variation to 6 inches. Click the Add button and choose the granite sphere to add it to the surface geometry list. From the Direction dropdown, choose Surface Normals and set the divergence value to 5. Select the Display operator in the second event and change the type to Lines. Choose the color swatch and set the color to a bright yellow. Change the red value to 255, the green value to 255, and the blue value to 10, and then click OK to accept the color. Now copy the MP world from the first event and instance it into the second event. This way, the particles in the first event and the particles in the second event will share the same world parameters. To accomplish this, right-click the MP world operator in the first event and select Copy. In the second event, right-click just below the Speed by Surface operator and choose Paste Instanced. You should now see that both MP World operators are in italic, indicating that they are instances of each other. Do the same thing with the collision for the fountain water. This time, make a regular copy. Right-click the MP collision for the fountain water in the first event and select Copy. Right-click at the bottom of the second event and paste the MP collision operator. These are two different ways of copying and pasting operators from one event to another. Now create a delete event. Click and drag Delete to an open area below the second event. For this event, you do not have to edit anything. You just want to delete particles that are going into the event. Where the real power of particle flow comes in is being able to connect a test operator to a new event, which creates a flow of particles from one event to the next. From the first MP collision operator, in the first event, for the granite sphere, click and drag from the output of the test to the input of the second event. Then, click and drag from the output of the MP collision for the fountain water in the second event to the input for the third event in order to delete the particles. Lastly, drag from the MP collision operator for the fountain water in the first event down to the input of the third event. This will delete any stray particles that bounce off of the sphere and hit the water directly. To see this particle flow in action, minimize the Particle View dialog box and click Play. At this point, it's running fairly slow. Stop the animation and go back to frame 0. Add one last operator, a cache operator, that will cache the particle flow down to the hard drive and speed up playback dramatically. You may have to scroll to the right in the operators list. Click and drag the cache operator to the PF source event just below the render operator. This will cause the cache to work on the entire flow. Select the cache operator. In the dialog, you can see that there are quite a few options available for what can be cached, how the cache is updated, and how many frames are sampled. To speed things up, sample every other frame. From the sampling dropdown, choose every nth frame. Change the n value to 2 and select Save Cache with File. For this cache, make sure the memory use limit is set to 200,000. In the Manual Update group, click Update to update the cache. Now, 3ds Max will play back the animation and create a cache for the particles. This may take a few minutes, but when the animation is finished, you'll be able to scrub through the timeline with much better viewport performance.